Hello, my name is Will Leger. I am a sophomore at Johns Hopkins University studying mechanical engineering. And for my dissection project, I chose to dissect a hand crank flashlight. I purchased these hand crank flashlights in a set of four for $13 on Amazon. I have reason to believe that they were manufactured in the previous year. The hand crank flashlight has two main methods of emitting light. The first is controlled by a crank, and the second is controlled by a switch. The flashlight also has another switch that holds the crank in place when fully squeezed. The first steps for dissection are unscrewing the main screws in the top of the flashlight. Once this is completed, the main frame can be taken apart and the switch and lanyard pulled out. As you can see from the image, there's a gear system that helps the crank generate power to emit light. The electrical system that is connected by the battery is controlled with a switch, as you can see here. As shown, once the crank is pushed, the gears spin, which spins a wheel with a magnet connected around an electromagnet, which generates power for the light to emit. The gear system consists of a standard spur gear connected to another spur gear on the same axle, which is connected to the crank, which acts as a rack and pinion gear, which turns the wheel connected to the electromagnet. The gear that connects to the wheel system is oriented in a certain way that allows for the push of the crank to create motion, but when the crank resets to its original position, it creates no motion. As you can see, the wheel that rotates has a magnet underneath, which creates an electromagnet with copper coils, which are underneath that middle part. The crank system all revolves around one axis, which is connected to the main frame by a torsional spring, which helps create the springiness that you feel from the crank. As you can see, there's a rack gear, which connects to the pinion on the underneath of the white gear, that helps translate that motion into torque. Finally, there's a lens and a lens case, which also covers the light, which prevents wires from being exposed to the outside. Through research, it is reasonable to assume that the crank flashlight shell was created through injection molding. Various safety hazards were taken into account for the creation of this product. One of the most important is, as it is an electronic device, no wires or electronics can be exposed, as they can cause a risk. Additionally, the crank flashlight was designed for children, meaning there should be no choking hazards or sharp objects that could hurt the children. There were many different types of loads that the frame took on from the system. One of the most important was from the torsional spring. As shown in these images, the force from the torsional spring caused the frame to break and crack. While these loads could be distributed more properly, the crank flashlight is a very cheap object, meaning it wasn't at the top priority of the designer.